This video is for the second half of the notes in section 10.4, which is finding the area of regular polygons with trig being required. What we are going to look at here is the follow-up to what you did in the previous day, where we did find some area of polygons with trig required, but the one difference was you were given the base, which required a little bit less trig and a little bit fewer steps. In this case here, what you are going to be given is the radius of the polygon, and we're going to have to go ahead and use that to figure out everything we need to ultimately find the area. So in this example here, number 4 at the top of your note page, we have find the area of a regular octagon whose radius is 16 feet. So keep in mind, the radius is, once again, you've got your center connected to a vertex, so the one of the corners. So I'm going to label in the drawing here, here's 16 feet. Now, in order to find the area of a polygon like this, you need two things. You need the apothem and you need the perimeter. Apothem you clearly do not have, because the apothem has to go straight down, as I just traced, from the center to the center of the opposing side. We don't have that. You also don't have anything for perimeter because you don't know the base of this triangle. You don't have any of the outer sides. So we are going to need to go find both these things solely based off the fact that we have this radius of 16 feet. So here's your process as detailed out here. First things first, we're going to go ahead and find the apothem. That's probably the easiest way to start. So in order to do that, you need a trig ratio, okay? You don't have enough info, you only have the one side. So we're going to use trig, using sine, cosine, or tangent to go find the apothem. So, as discussed in the previous part of this lesson, you need this top angle here, right where the apothem and radius meet. So to get that angle, you need 360 divided by the number of sides. In this case, it's an octagon, so divided by 8. And then we're going to go ahead and cut that in half. The top angle is going to be 22.5 degrees. That's what we're going to use here as a point of reference. So for this first step here, I'm going to go ahead and just redraw the triangle so it's a little bit bigger. So we have 16 in your apothem, and then this top angle here is 22.5 degrees. Now, based on the location of the angle and the two sides that are labeled, we are going to use the cosine function, because cosine is going to relate the adjacent side, A, to the hypotenuse, 16. Cosine 22.5 equals A over 16. We're going to go ahead, multiply each side by 16 to get the A by itself. So we'll have 16 times cosine of 22.5 equals A. And then you just got to punch that in the calculator. That will give you an apothem of 14.78 feet. So that's one of the two major bits of info that you need. You need the apothem and you need the perimeter. Apothem is done. Now we need to go find the perimeter of the shape. But in order to find the perimeter, you need the base of the triangle that you started with here. So what I'm going to do here is I'm going to go ahead and redraw this triangle. So here's what we know. We know the apothem is now 14.78. We know the hypotenuse is 16. We also know this angle up top here is 22.5. And you have a base down at the bottom here of x. We need to go find that. Now, there's two ways you can do this. You can either use trig, relating one of the two sides to the x and that 22.5, or, since you know two of the three sides of a right triangle, use Pythagorean theorem. I'm going to go ahead and use Pythagorean theorem because I feel like that is something more of you may be comfortable with. If you want to use trig, the trig might be a little bit faster for some of you. Either way, it's fine. You'll get results that are very, very similar to each other. There might be slight errors in rounding, so your answers could be hundredths or even thousandths of a place value off, but they will be in the same ballpark. I'm going to go ahead and do, once, like I said, Pythagorean theorem. So we know the x and the 14.78 are the legs, 16 is your hypotenuse. So from there, goal is to get x by itself. So we'll have x squared equals 37.55. And that base is equal to roughly 6.13 feet. Now, this part is very, very important. And this is the part, you can do all this great work here, and this is the part that can mess you up. You need to find the perimeter, which means you need to know a full side. Right now, you've only found half a side. So if you look up here at the top of the picture, I'm tracing that in red. What you really need is the full side. Not just that half, you need the full thing. So in order to get that full side, not complicated math, but you have to remember to do this, okay? To get the full side, we're going to take whatever you get for x, and we're going to double it. So to get the full side, we're going to double the x value in this case. Because what you were given, this x value is only half the side of the polygon. We need the full side. So all I'm going to do to get the side, I'm going to take that 6.13 times 2. So really, one side is 12.26 feet. So once we get that side, we can now go to the third step, which is use the length to find the perimeter. Well, this step is probably the second easiest out of all of them, because to find the perimeter, if you know one side, multiply by the number of sides that there are. In this case, it's an octagon, and you can see by the picture there's 8 of them. Altogether, it's going to be a perimeter of 98.08 feet. You now have the two pieces of info that you need in order to calculate the area. You've got the apothem, you've got the perimeter. So final step, use your formula. So 1/2 times your apothem, which is 14.78, times your perimeter, which is 98.08. You will get a final area of 724.81 feet squared. So what we are going to do here is I'm going to model this here with the final two examples in the notes. So numbers 5 and 6 are very similar to this process. Your numbers are going to obviously be different here, but it is a very similar step-by-step process. So we're going to go ahead in each problem, find the apothem. We're going to go ahead and find the length of one of the sides so we can find the perimeter, and then use both those things to get the overall area. So let's take a look here at number 5. So once again, I give you a radius. It's 3. I'm going to go ahead and create that little right triangle. And again, we're going to focus on finding the apothem first. So the key to finding the apothem, we need the angle of this triangle that's been formed here at the top. So to get that, 360 divided by the number of sides, which in this case is 5, cut in half. We end up with 36 degrees. So let's go ahead and start with finding the apothem. So once again, we're going to use a trig function here. So we've got 3 on the hypotenuse. You've got A, and then you've got the 36. Once again, we're going to use cosine because the A and the 3 are adjacent and hypotenuse respectively. So cosine of 36 equals A over 3. Multiply each side by 3, so we get 3 cosine 36 equals A. Punch it in the calculator. Your apothem is 2.43 inches. Not going to box it here because that's not my final answer, but we are going to need that here a couple of times. Now, we've got the apothem, so now I'm going to go ahead and we're going to go ahead and find the missing side. So, once again, the missing side is the bottom, that's your base, that's X. We've got your apothem, and you've got, the apothem and the hypotenuse here, your radius. You also still have that angle. So again, while I'm going to continue to use Pythagorean theorem, you can feel free to use trig to find out the missing side as well. And again, you'll see that you get a very comparable value. So, Pythagorean theorem, x squared plus 2.43 squared equals 3 squared. We get the x squared by itself at roughly 3.10. And then the x value is 1.76. Remember, crucial step, we want the whole side, not this partial side. So we take this value, we double it. Once you get that x value, you're going to double it, and you'll get 3.52 inches. Which then also means we can go find our perimeter. One side is 3.52 times the fact that we have 5 sides. Means we have a perimeter of 17.6 inches. Okay? So we have the apothem. We've got the perimeter. I am going to star those because that way when you look back in your notes, you'll see where you get these numbers from. And now we're going to go ahead and do the easiest of all the steps. Plug the numbers in to go find the area. So that'll be 1/2 times an apothem of 2.43 times a perimeter of 17.6. After all of that, you get an area of 21.39 square inches. Now we're going to go ahead and complete the final problem here, number 6. You'll notice again, the radius is in the same spot. It's once again another radius. We're going to go ahead and do, again, all the same steps one more time, so you can see exactly what is expected here when you are given just a radius. So, last time here, number 6, we've got a radius. Great. We're going to go ahead and draw in the apothem. This angle up at the top, once again, 360 divided by number of sides, in this case 8, cut in half. Hey, look, it's another octagon. So it's going to be very similar to the example actually up above. It's another octagon. We're going to have another 22.5. So we're going to see some similar numbers and some similar functions and operations here. So let's go ahead and find the apothem first. So our top angle there is 22.5. You've got your adjacent side A, your hypotenuse 17. You've got yourself another cosine problem. So cosine of 22.5 equals A over 17. And then we're going to go ahead and get that A by itself. A is going to end up equaling 15.71 meters. And again, I'm going to star it just because we're going to come back to it here in just a bit. Clean that up here a little bit just to make that easier to read. So A, once again, that equals 15.71. Now, we're going to go ahead and we're going to go find our base so we can go ahead and find our perimeter. So go ahead and label everything. Once again, we now know the perimeter, or excuse me, we know the apothem is 15.71. The radius was 17. You still have your angle at the top. And again, you want to use trig for this, great. If you want to use Pythagorean theorem, that's what I'm going to show you here. So, x squared plus 15.71 squared equals 17 squared. You end up with x squared equals 42.20. Your x is equal to 6.50. Once again, that is only a partial base. It's not the whole side. To get the whole side, you must double this value. So 6.50 times 2. This one actually comes out nice because of the way things initially rounded. A side is going to be 13 meters. Which then also means your perimeter can be found. One side is 13 times the fact that you've got 8 sides. You've got a perimeter of 104 meters. So now you have the two things you absolutely must have. You've got your apothem. You've got your perimeter. Let's go ahead and just plug everything in. So, 1/2 times 15.71 times 104. Your final area is going to be 816.92 meters squared. And that is how you go about finding the area of some regular polygons when you are given just the radius of the polygon. So, if you are a little confused at any of the steps, my suggestion is go ahead and rewind. Try to listen to the steps through again. All three problems here are very similar to one another, and the problems in your homework that go with this are similar as well. For the problems that are like this in your homework can be found on page 5. It's the second part of the 10.4 assignment. I believe it's numbers 5 through 8. So 4 problems that are practiced, very similar to the ones presented here in the notes. Again, try to rewind, fast forward, go through the steps again to figure some of these out. If you have questions on any of these, please feel free to shoot me a message. I'll do the best I can to explain it once again. Thanks for watching.